Hi, so on today's video, we're going to be looking at CTEs, common table expressions. So, common table expressions are an improvement to subqueries. So, in this video, we're going to look at how they compare with the subquery. So, we're going to create a subquery and then we create the CTE version of it. And also, we're going to look at how well they rearrange the code and they make it readable. And we are going to look at connecting or joining two CTEs, multiple CTEs, such that they look as different tables that you're joining. So let's get right into it. So let's start. And so this is our table. So select all from employees table. So we have still the same table that we used for the subqueries. And we have five columns. We have the employee ID, name, department, age, salary, and we have 27 rows still as the same uh, table that we had working with subqueries. And so looking at CTEs, I want us to compare CTEs and subqueries. And so we're going to be doing a query where I will compare the subquery form and the CTE form. And first question that we're going to be answering, first to answer will be which department has maximum salary below 60,000. So in which department is the maximum salary below 60,000? And so we're going to be using a subquery to get the answer this, then we use a CT version to get an answer to this. So you're going to start with the inner query. So select department, then max salary as max salary. So then from employees, so remember you have an aggregation function, the max, so you have to group by everything before that. So group by department. So this is the inner query. So we have, so the maximum salary in each department is this: finance 77k, sales 51,000, IT that, and HR 55k. So let's get the main query. So we'll be select everything from that. So this will be our inner query, and we have, so let's make this subquery so that, so main query where max salary, now this a derived column, max salary $60,000 is less than 60,000. So you have the sales 51,000 and HR 35,000. So let's see the subquery or the CTE version of this. So we're going to be this query, just this inner query is what you're going to be using. So let's copy that. So let's say the CTE version of this, of which department as a max salary below 60K. So this subquery, remember, and so I'm going to what makes the distinctive characteristics of a subquery is this statement. So with, so let's give this subquery or CTE a name, maximum salary, MS. So yeah, so let's, yeah, so that's a table. So basically a CTE now we'll query this from, basically it seems like a table. We'll see this when you are using multiple CTEs and they will act as two tables actually. So let's see. So let's query. So select. So now we are querying this table. So it's a new query. So select star or everything from now this MS from this CTE where maximum salary is less than 60,000. So let's run this. Sorry, so we did not put the S statement. So with MS as, sorry, so the distinctive is with the name of the city and as S. Sorry. So yeah, so we have still brings the same result. So if we can make this good. So yeah, so well, as you can see, it's more organized, and some advantages is a cleaner look, and for complex queries CTE is the way to go. So subqueries, they are used in older software, although now they are becoming used in new softwares that are incorporated, and they are better while handling simpler queries. So we're going to be looking at advanced. So we're going to be multiple CTEs, multiple CTEs, and we'll be be looking at employees with age above 30 and compare maximum salary in their departments. So probably a reason that I'm looking at this kind of queries, I want to look, do you get in this organization, this particular data, do you get more benefits or more salary as your age increases? And so let's look at that. So the first data will be this table. So this CTE is all of it. I'll be getting it. So this will be our first. So copy. So yeah. So that will be our first. And then I want to be looking at the employees whose age is 30 and compare. So very simple approach. So you don't need to create another with dash as. So you just put a comma there, and age as. So you'll be selecting everything from our table, from employees where the age greater than 30. Yeah, so this will be our other CTEs, and so we are looking at combining them. Yeah, so let's combine them. So we'll be selecting, be joining them rather, select everything from now our first table. We want everyone in our age. So this will have to be a right join, a left join, sorry, and age will be a first table. So age, then left join ms on age. The column, similar column is department equals ms dot department. So let's look at this. Yeah, so the output, and so we have 12 employees above 30, and their age is almost, so we have 53 to 55, 63 to 65, 47 to 51, 46 to 51, yeah, so, and 51 to 51, 77 to 77, yeah. And so basically brings us to the fact that, so our demograph, so slightly, so our oldest employee is 36, yeah, in this 37, sorry, in this data. And so we can be able to prove that experience or age equals higher salary, higher to almost the maximum salary in each department. And yeah, so this is how we go about it. This is how we can conveniently do subqueries and convert them to Cte versions and join multiple Ctes in a query. Yeah, and so Ctes are great. And if you are not using them, you need to start right now. Yeah, so Ctes are used by DBT to do data transformation in the data warehouse. And in a series that we'll be also learning how to do this with using DBT, we'll be using Ctes only. So there are no other. We don't use subqueries, don't use anything. So we use Ctes for all that dimension modeling. Yeah, so that will be all for today. Till next time, bye.